In this video, we are going to discuss what are the conditions of the equilibrium of three coplanar parallel forces. What are the conditions? First of all, let us take the three forces D, Q. Let us take the three forces D, Q, and R. They are parallel forces, and the three forces are in equilibrium forces, and they are acting at a single thing. For example, suppose we take any particle like this, and any two forces, the three forces are parallel forces. Therefore, the parallel forces are maybe the three forces are like parallel forces or unlike parallel forces. For our convenience, we take the force D acting this direction, and the Q is also acting the same direction as D, and also Q is parallel to D, and the third force are suppose the third force also acting the same direction as D and Q, then the equilibrium is not possible. Because the resultant of dq are equal to the algebraic sum of all the forces. They are they are parallel forces. Suppose the dq are the same direction, that is like parallel forces, then the resultant is equal to b plus q plus r. Then the equilibrium is not possible. Therefore, this case is not possible. Therefore, the third force R must be opposite to D and Q, but parallel to D and Q. Let us take the line of action of these three forces such, that is the like this line. That is the force B acting at a point A, and the force B Q acting at the point B. Then what is the resultant of D and Q? Okay. The resultant of D and Q is equal to B plus Q. The algebraic sum of B plus Q. Okay. And the resultant is parallel to D and Q, Therefore, the force R, the resultant of D and Q equal to B plus Q, which is parallel to D and Q, B or Q. But we are assumed that B, Q are equilibrium forces. Therefore, R must be equal to B plus Q. Then only the equilibrium is possible. That is, therefore, R is equal to B plus Q, but R is the direction of R is the opposite to B and Q, B plus Q, the opposite to B plus Q, Okay. Therefore, we get that R equal to the algebraic sum of B plus Q. Okay. Algebraic sum of B plus Q. But it acting at a point C. The result in R acting at the point C. Therefore, we get that B into AC equal to Q into CD. Therefore, this implies that from this equation we get that B by CB equal to Q by AC. B by CB equal to Q by AC. from this equation we get that each ratio equal to, from this equation each ratio equal to that is b plus q, each ratio equal to b plus q divided by cb plus ac, cb plus ac, cb plus ac, but this is equal to, but b plus q is equal to r, b plus q equal to r, and cb plus ac equal to cb plus ac equal to ab, cb plus ac equal to ab. Therefore we get that, b by cb, b by cb is equal to, b by cb equal to q by ac, q by ac, but this is equal to r by ab, r by ab, r by ab. Therefore we get that, or we get that, that is thus if thus if the three forces, three parallel forces are in equilibrium, then each is proportional to, that is each force is proportional to, each ratio is proportional to the distance between the other two, forces. Thank you.